This is Mr. Anderson for Kellogg Community College. We're looking at Chapter 5, Section 3 of Math 121, Intermediate Algebra. We're going to be looking at ways to factor and the reason why we factor. And in Section 3, we get into actually the first two types of factoring, and they're very, very important. This is pulling out a common factor or grouping. Now, there's a very good question about why we factor, and it has to deal when we have an expression like this, where there's an x squared, another x, and a problem, because we need the skill of factoring to get to a point where we can solve for x. Let's say I set this equation equal to 0. We can find out when this does cross the x-axis, and the answers would be -3 and -1. But to get from here to here, we would actually need the skills of factoring, and that's really what this chapter is about. When dealing with a nonlinear function or a polynomial, we need factoring to solve for x. So let's go with some of our examples here. The first and most important step of factoring is to factor out a common term if possible. Now, the common term is something that every term has in common. Like, for example, you'll notice that these three terms in this polynomial each have an x. So this is something we can factor out. And we do so by using a reverse distribution property. So you might be thinking that maybe I can divide each of these by 3, because I'll notice this is a 9 and a 3, but this technically has a 1 in front of it, and the only number that can divide 9, 3, and 1 is itself. We'll never factor out a 1 in the first step here because it really doesn't help us. But by factoring out a common term in the start of the problem, what we can do is we can really simplify our work here. So this will become 9x squared minus 3x. Notice that each of these go down a power when I pull an x out, and then this is minus 1. And this does not become a 0 here. Some people believe that, well, I pulled the x out, so wouldn't this be a 0? No, you actually just removed an x from each term. You'll never end up with fewer or more terms than you've had when just pulling out a common term. In the next problem, your job is to pull out the biggest factor. Don't just pull out a 2 or a 4. Pull out the biggest term possible. So this would be 8. Now, the biggest x we can pull out is an x cubed. And the reason why that's the biggest is because that's all what each of them has. You can't pull out more x's than the one that has the one term that has the fewest. So this is going to be 2x to the 5th. This is going to be 5x cubed. And finally, the answer is going to be 3. Now, you'll take a look at the exponent rules. 8 minus 3 is 5, 6 minus 3 is 3, and 3 minus 3 is 0. X to the 0 power is right here. X to the 0 is technically 1. I'll write that down here. So anything 8 to the 0 power is times 1, so that's why it looks the same. Now, here's Anderson pro tip number 1. The first pro tip I'm going to give you is that if you have your leading term has a negative coefficient, what you should do is pull out a negative. And the reason why we want to pull out a negative is because that will make your factoring much easier. When you get to some of the more difficult factorings in section 5.2, the hard section, we're going to want a positive number in the front of this problem. So what this will do is this will mean that we easily factor out a problem with a negative in front. So the biggest number that can factor out these three terms are -6. It's the biggest absolute value of that number, and we want to factor out the negative because of my first pro tip here. And how many x's can I pull out? I got a 5, 4, and 3. I can pull out 3 of them. And then how many y's? 2 is the answer to that one. And then we put our parenthesis here. So -42 divided by -6 is going to give me a +8. This is good. We want our first factored, the first term inside of this parenthesis, this trinomial, to be positive. We're going to have 2 x's left and no y's. And then we're going to have a minus here because this is a -18. And this is going to be 3. There's going to be 1 x left and 3 y's. And then finally, this is going to be positive again. 6, and there we go, is going to be a +4. And we're going to have no x's because we pulled out 3 of them, and only 1 y. So that is our common term factoring. All right, for the last half of this, the second technique, which we'll be using for the more difficult problems, is to, looks like I'm going to have to scroll down after a little bit here, factor by grouping. Oops, let me get my pen set up. So factor by grouping. Now, what's really great about factoring by grouping is that you'll have four terms. When you see four terms, you you're going to factor out two terms from the front two and then two terms from the back two. And if you get a matching pair, what that gives you is going to be a factorable and wonderful answer. And it's going to seem like magic at first, but there's kind of a neat little proof here that will kind of see why it works. So you'll notice that in these four terms, there's not a common factor. Like there's no A's in all four of these. There's no C's in all four of these. There's no D's in all four of these. There's no, so there's no letter in common with all four. But in the first two, I can factor out an A, which will give me D plus C in parentheses. So again, just looking at the first two, factoring out the first letter, then or a letter that they both have in common. And in this case, you'll notice that there's a C in common. So I'm going to put a plus C because the C is positive, and then I'm going to put D plus C. Well, here's the great thing. If you get to these two numbers all by themselves, put them into their own parenthesis, A plus C, and then put this, do you see this matching set, D plus C? Put them into their own parenthesis, D plus C, and now it's factored. If you do your FOIL, first, outside, inside, last, you'll see that it'll make these four terms right here. But the reason why I could go from this stage to this stage, this A parenthesis D plus C parenthesis D plus C, is because this is just an application of the distribution property. If I had A times X plus B times X, that would be the same thing as A plus B times X because of the way that the distribution works. Distribution works in this way, like you would have jumper cables going here and here. So follow it from this step all the way back up to here. You can see where this bottom step can be brought up to this top step. And if that's the case, we can do the same thing from this actually back to this right here, and you can see that you can kind of reverse this. So this does seem like magic, like the ones that were outside got together and the pairs became one. It's because of this little quickie proof right here, where if I have an X that's on the outside of a parenthesis set here, I can distribute that in and make it look like this, and vice versa. So this is factoring by grouping. Okay, the proof again may seem a little weird here, but taking a look at this here, it actually does work. Foil it out, see if it gels with you. Look at these two terms right here. I'm going to have b squared, and then I'm going to have b minus 1. That's what they have in common. And then here I can factor out a 2, which gives me b minus 1. And b squared plus 2 is going to be the two that are separate, and then the ones that are together, b minus 1. Check it out, the foiling, whoops, didn't mean to put 2 there. The foiling does make this work. And now for the next couple problems here. These are all trick problems. They all have like little quirks to them. And I'm going to get into Anderson's pro tip number 2, especially with this problem here. And the reason why I want to highlight it as a pro tip is that many problems in your book will seem unfactorable, but they're really factorable. So if I factor an a squared out of the first two terms, I get a minus 3. Then in the second two terms, you'll notice that this is a negative. Anderson pro tip number 2, put a little star here again. If you can pull out a negative in the third term, it's probably the best thing to do so. So if I pull out a negative 2, then I get a, instead of a plus 6, I get or a plus 3, I get a minus 3. Because that negative 2 has to change that to its opposite sign. So this gives me a squared minus 2 and a minus 3. And there's my factored form. How about here? What can I factor out of these terms? So I can factor out x squared, so I get x minus 1 Now you'll notice that there's nothing I can factor out here. So in this case, when these two terms are completely unfactorable, you will factor out a 1 and see if you get inside of your second parenthesis what you did in the first one. And since it was a match, we have x squared plus 1 and x minus 1. And that's a factored form. FOIL it and you'll see that it's okay. Now, why is this a problem? It's a problem because the book didn't put this in alphabetical order. And by alphabetical order, I really mean in descending power order. Oh, wow. So x to the 6th minus x to the 5th plus x minus 1. So you put things in descending powers of x. Then once that's in order, you can go x to the 5th and go x minus 1 here, because you can pull x to the 5th out. In the second terms, you can pull out a 1. So this is x minus 1. So what I'm left with is x to the 5th plus 1. And whoops, I shouldn't have an equal sign there. And another set of parentheses, x minus 1. And if you FOIL that out, it will work. Now you'll notice that these first two terms do have a y cubed and a 4 in common, but you'll notice that all of these numbers also have some y's and 4's in common. So what's a good idea is to pull out a 4y at the start of the problem, and that way we get y cubed. This is going to be another 4-term polynomial here, plus 3y squared minus 4y minus 12. Now what I'm going to do here is change colors and show you the blue parenthesis. The blue parenthesis is going to get factored again here. What do the first two terms have in common? They have a y squared in common, and that leaves me with y plus 3. And remember, in the second pro tip here, if you see a negative, pull out a negative. So this is going to be, I'm pulling out a negative 4, and that's going to give me a y plus 3. What's great about that is now my answer down here for what's in this light blue here is y squared minus 4, and then y plus 3. Now I have to put back the term I factored out from the very beginning of the problem. So let's go ahead and do that. It has to be part of your answer. It does make what's inside the light blue a lot easier to factor. And what this will do here is it'll get you, it'll basically make your problem 4 times smaller is a rough way to put it, but when you're doing a lot of combinations, pulling it out by a magnitude of 4 is really going to be important. Now, you'll might, to prove to you that you really do need some factoring review, you might be looking at this and saying, oh wow, that's the answer, right? Well, it's not the final answer, because if you had all of your factoring skills, you might notice that this term here, this y squared minus 4, is y plus 2y minus 2. It's a difference of squares. And that's what we'll be covering in chapter 5. I believe it's section 5. So you may want to brush up on your skills if you didn't recognize that this was also factorable. This is not factorable right here. This is not x plus 1, x minus 1 for reasons that we'll discuss in that section. But this is probably good proof that you need to get started on your homework and practice factoring, because these can be tricky, because even though when you feel like you're finally finished, there might be 1 or 2 things left to do. Well, thanks for watching.